So 3.3 is properties of logs, so it's moving on more into those log graphs. We talked about our natural base, and we have some bases that'll be like log base 2 that you can't plug in the calculator. So if it's something you can't plug in the calculator, we still need a way to find those answers, and it's called change of base. Right, so if we want something that's not base 10 or not base E, we need a different way to come up with those answers. And down here is my solution. So if I have, it's a little hard to see, if I have log base A of X, you do log X on top, log A on bottom. So now I've turned them into base 10s that I can turn into my calculator. And the same thing works with the natural logs. So if I want to change a base here for log base 4 of 25, you're going to put in your calculator log of 25 over log of 4. And you have that log button in your calculator. Type it in, get your answer from there. Same concept here, Matthew, when you do log base 2 of 12, you're going to put log of 12 on top, log of 2 on bottom, type it in, get your answer from the calculator. Okay? This change of base formula is something that you need to have memorized. I'm not going to give it to you on tests and quizzes, but you're going to want to have that. It's very nice, very easy to answer things with that problem. Okay, so the top one is about 2.3 and your bottom one was 3.5. All right, so here dealing with our properties of logs. Another property you want to understand is if I have log and I'm multiplying two things inside the log, you can expand them by adding. So the opposite of multiplying would be adding them. You still have log base A of U, log base A of V. So the base stays the same. All I'm doing is expanding this to adding two different things instead of multiplying inside. So if multiplying is addition, when we talk about division, it's going to be subtraction. So if I want to take these two that are inside my log and separate them, it's going to be log AU minus log AV. Okay? Anytime you have an exponent, the exponent is going to come out in front of the log. So beyond Matthew's pretty picture here, you pull that n out front of the log, and now it's n log base A of U. Okay? So these are the main properties you need to understand when we talk about expanding and condensing logarithms. All right, so we're going to look at this one. It's negative log base 10 of 1 over 100 equals log base 10 of 100, and I want to use my properties to verify, that means prove, that these two things are equal. So remember, in a proof, you want to make sure that you're only using one side. So I'm going to leave one side by itself, and the other side I'm going to go ahead and change up. Okay, so when I'm looking at it, again, it is 1 over 100. I'm going to go ahead and rewrite that. This is my left side. I want to think of that 1 over 100. I'm going to rewrite it with my exponent rules as 100 to the power of negative 1. So when I do that, (100 to the power of negative 1), you have your rule where any negative out front you can pull up here, right? So if this is a negative 1 out front, I can pull that up into my exponent. So instead of having it out front, I now have to the negative 1, negative 1. When I do that, that's going to give me my positive 1. All right, so when this gives me my positive 1, you've got just log base 10 of 100 to the power of 1, which is what my original was.
Mommy.
Hold on. All right, so this is expanding and condensing. We're going to use those rules. So when I look at this, I'm multiplying here in between. I'm going to start out by expanding them with addition, so log base 4 of 5 plus log base 4 of x to the third plus log base 4 of y. The third is on the x, it's not on any of the others. The last thing I want to do is move this exponent out front of my log so that my final answer has, instead of it in the exponent's position, it has that 3 out front. And this would be a full expansion of the original log. Why do we expand and condense? We do it later for properties and verifying for proofs. So the condensing here would be looking at your exponent first. So I have a 2 out front, which means I want to pull that up here. Now that's going to go, this is the entire natural log, so that 2 up front is an exponent to that whole piece. And then we've got a subtraction. The opposite of subtraction is division. So on top I'm going to have the natural log of x plus 2 squared divided by the natural log of x. Because my logs are the same, when I condense them, I want to have as little written as possible. So instead of writing both on top and bottom, I'm going to write ln of x plus 2 squared over x, and that would be your full condensed. Alright, so here's a couple more that you can try out. This one would be expand, so try this on your own, see what you come up with. Now the answer is going to be looking at the natural log of root 3x minus 5 minus natural log of 7, because you're dividing, so when I expand them, I'm subtracting. This root becomes a 1/2, right? So this is like saying 3x to the negative minus 5 to the 1/2. So I'm going to pull that 1/2 out front. Natural log of 3x minus 5 minus natural log of 7. And then that would be it. For condensing, go ahead and try that one. So again, my 1/2 is going to turn into the exponent over here, which is a root. So I've got log base 10 root x plus this becomes my exponent up here. So log base 10 of x plus 1 cubed. Because I'm adding, I'm really going to multiply when I condense them. So my final is log base 10 of root x times x plus 1 cubed. So that would be your condensing. All right, a couple more examples. Try a couple of these out right here. So again, you've got your 1/2. So for the one up top there, we've got the natural log of x squared to the 1/2, and then y cubed to the 1/2, because I'm giving that root to both powers. My 2's here are going to cancel. This is going to become the natural log of x over y to the 3/2. I'm expanding this one. So I split that up, it's division, so it becomes subtraction. Natural log of x minus natural log of y, and that exponent is going to come out front of that natural log. Okay? The first one was just natural log of x, y, z. So those are all multiplication, it all expands. Natural log of x plus natural log of y plus natural log of z. Okay? The last one is condensing. Again, this 3 comes up as my exponent. It was subtraction, so it becomes division. ln of x over x plus 1 to the 3rd power.